Hello everyone. My name is Sainath, and I, along with Hastik Vaghasiya, are going to do a project presentation on customer acceptability evaluation on cars and its analysis using SVM model. The first few minutes, I'll explain you the stats of cars, the history, the evolution of the cars in last 1 year or 100 years, and the features that have been added, and how the consumer demand has been growing. What are the expectations of the consumers, etc. And the second half is going to be explained by the Hastik on the analysis of the acceptability of cars by the customers using an SVM model. Cars in last 100 years. So cars have been the main mode of transport in last 100 years, especially in last couple of decades. So almost all the major countries have adapted to use cars in their countries as a primary mode of transport for local commutes. So the main reason for the growth or the surge in car manufacturing is the growth in global macroeconomic conditions and rise in world GDP, along with the consumer demand on cars and other consumer goods. So, as I mentioned, almost all major countries have adapted to use these cars in especially last couple of decades. Some countries like US have been a great market for the industry, where cars have become necessity for every family. So there are many examples, or there are many individuals who own cars in US before owning a house and all. So that is how important and necessity the car has become in developed countries. Some statistics on cars in the recent times. So approximately over 50 million cars are sold in 2019 worldwide, of which US market alone contributed 17 million cars. So US, of course, is the biggest market for the cars, along with the Europe and some countries like Russia and China. So 2019 alone has contributed 50 million cars, and there's an estimate of 70 million cars to be sold in 2020, the starting of 2020, but maybe COVID has impacted that numbers in 2020. So some major car producing countries are China, Japan, Germany, USA, South Korea, etc. And the leading car manufacturers are Volkswagen, Toyota, Hyundai, GM, Honda, etc. So some newer manufacturers like Tesla have been attracting a lot of customers in recent times, but they're not as big producers as Volkswagen or Toyota yet, but the growth is very fast for some modern companies like Tesla. They have electric cars and many modern technologies. So the consumer market is also mainly in Europe and US. They are the biggest markets of passenger cars, followed by some Asian countries like Russia and China. So all these facts are gathered from the site 25 Amazing Statistics on how consumers shop for cars. So here is the evolution of the cars in last 100 years. So these are some of the major features that have been introduced to the cars over the time. So though cars have been introduced before 1886 or 1890, it has been introduced to the public, or the public mass production has been started around 1886. So car radio has been introduced in 1930, coil spring suspension 1934, etc. And air conditioning is one of the major feature that was introduced in 1953. Airbags is one of the major safety feature that was introduced in 1988, and anti-lock brakes also in 1971. And most recent advancements are hands-free Bluetooth, driver assist features, and the current major enhancement to the cars are self-driving features. So almost all car manufacturers are trying to introduce self-driving feature in the cars. Tesla is little forward among all the competitors. Car evaluation criteria by consumers. So let's mainly concentrate on the main topic now. So many car manufacturers are trying to meet the consumers' demand and understand what is the criteria, what are the features the consumers are looking at, how are they picking the cars from the market. So with more value given to the time, consumers evaluate new cars by their efficiency, safety, autonomicity, and also design. So manufacturers are trying to improve these features and concentrate more or put more money on some of these features which are in high demand among the consumers. So manufacturers try to understand consumers' demand by analyzing their evaluation criteria by the consumers. Different machine learning techniques are being used by the manufacturers to produce the right car for the consumer base. To understand the right feature for the right consumer base, different machine learnings are introduced by the are being used or performed by the analysts for the car manufacturers. So we also try to do a similar analysis based on data we have. For example, like the buying or the number of doors a car have, which comes under design, and the safety features the car has, and so on. And we try to do different models, and we have decided to perform the SVM model on this data set, and Hastik is gonna discuss more about the model in the next slides. Thank you.
I am going to explain the implementation and its analysis. For the implementation, we are using support vector machine, SVM, and random forest. First of all, I would like to explain why we are using support vector machine. The reason behind using SVM is that it works very well in high dimensional feature space. What does it mean? It means that when we are having large number of feature and large number of data set, all the data will be divided into different dimensional, and using the distance and vectors from all the data point, it will help model to get correct prediction. Using SVM to train dataset is very easy. And the third reason is that it scales relatively well to the high dimensional data. That means that when we are having very large number of data, SVM would be a good option. We are also using random forest in our implementation for comparing how SVM performed and how random forest will perform. So why random forest? Because it divides all the features as a subset and then it forms a tree-like structure. So it is a decision tree model. And second reason is that the performance level is high with less need for the interpretation. As we know that it is forming a decision tree, like say first node would be one feature, let's say a safety, and second would be subset would be something like yes, it is safe, or no, it is not safe. The feature would be divided in the random basis and the splitting on the random subset of features. And random forest also take less data pre-processing. Because of that reason, it is very fast for the execution. We are using feature extraction to select the number of features and pass that feature to our model. Feature extraction is important because it limits the number of features, which makes the model run faster. We are using select k best method to extract a feature. What the method will do, it will take all the features and the output of that, and it will process to find out which features are significant. In our dataset, there are many features such as buying, maintenance, doors, persons, luggage boot, and safety. And among them, select k best method selected the features which are significant, such as buying, maintenance, persons, and safety. It also helps the algorithm to run faster because there are limited number of features to predict the output. It also improves the accuracy level and reduce the overfitting in the model. SVM architecture. It is built in a way that first it will take the training data set to get the feature samples. That feature samples is then passed to the SVM classification model. The model will break down that samples into different data points in three-dimensional feature space. All that divided portion will be classification as a C1, C2 up to Cn. Using SVM, we maximize the margin of the classifier. After the model has been built, we will pass the testing dataset to our model, to our classifier to get the prediction. We have passed same dataset to two different models. First one is the SVM and the second one is random forest. Both the techniques are good for classification. Random forest technique has accuracy of 87% and SVM has accuracy of 89%. So comparing both the techniques, SVM has a performance better than the random forest. Confusion matrix is used to evaluate how the model works. As we can see, the precision for predicting the acceptable is 71%. That 71% because of 90 predictions, 26 were wrong. So when we do the calculation, 64 divided by 90, it will be 71%. In similar way, we can calculate the precision for others. We have recall of 93% for the acceptable, which means that out of 69 actual values, 5 were wrong. In calculation, it will be 64 divided by 69, that would be 93%. And in similar way, recalls are calculated for all the output. Total accuracy is of 89%. In conclusion, with a very large data set, what random forest will do, it will take lots of memory due to the size of the trees. And what SVM will do, it will use its feature space to distribute the data point, that is features. So with very large data set, SVM would be a good option for implementing. SVM is very less risk of overfitting. And when we evaluate using the confusion matrix, it shows that SVM model provides a better accuracy level than the random forest. So in the final conclusion, with very large data set with many number of features, SVM would be a good option.
Thank you.